right, so this next lesson is on adding and subtracting rational expressions. Okay, and in order to add or subtract a rational, you have to have a least common denominator, just like you have to have a least common denominator with fractions. So we start by looking to see if the denominators have any common factors. We're going to want to multiply each factor once and only once, and then find our equivalent fractions by multiplying our numerator and our denominator by the same value. So here we're not actually adding these fractions together. We're only finding the least common denominator and writing equivalent fractions. So my LCD, least common denominator, 5 and 2 are what we call relatively prime. They have no factors in common. 5 is 5 times 1 and 2 is 2 times 1. So I can multiply them together and my least common denominator is going to be 10. Now to write my equivalent fractions, I have 3/5 times something will give me something over 10, and 1/2 times something will give me something over 10. Okay, 5 times 2 is 10. Whatever you do to the bottom, you have to do to the top. 3 times 2 is 6. So my first equivalent fraction is 6/10. 2 times 5 is 10. Whatever you do to the bottom, you have to do to the top. 1 times 5 is 5, so 5/10 is my second equivalent fraction. For number 2, all right, 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3. Okay, we do have common factors here, right? I've got the 2's in common and another set of 2's in common. So when I find my LCD, now hang with me, I know you know it's 24, but hang with me, right? My least common denominator, I'm going to multiply 2 times 2 times 2 times 3. 8 times 3 is 24. That's my LCD. I want you looking at what we did with the common factors because that's going to apply to polynomials. All righty, let's do equivalent fractions. 7/8 times something will equal something over 24, and 5/12 times something will equal something over 24, and 8 times 3, so 7 times 3. First equivalent fraction is 21/24. 12 times 2, so 5 times 2. Second equivalent fraction is 10/24. Now let's do this with polynomials. These polynomials are already factored, which is really, really nice. So my first one has x minus 4, and my second one has 2 times x minus 4. What I have in common are the x minus 4's, so I'm only going to include that once in my LCD. My least common denominator is 2 times x minus 4. Okay, so equivalent fractions. I now have 7 over x minus 4 times something will give me 2 times x minus 4. And I'm also going to have to do x over 2 times x minus 4 times something will equal 2 times x minus 4. Okay. X minus 4, I am missing the 2. So I'm going to multiply the top and the bottom by 2. And the first equivalent fraction is 14 over 2 times x minus 4. My second fraction, I already have the common denominator. So technically, you are multiplying by 1 to get that equivalent fraction. And now we would be able to add or subtract those two fractions together because we have a common denominator. So now let's try it with a set of denominators that has not been factored for us. Okay, LCD. This first one, nicely done. Our second one has to be factored though, and we have x plus 3, x minus 2. So the common factor is x minus 2. I'm only going to count it once. My LCD is going to be x minus 2 times x plus 3. So as I go to write these equivalent fractions, I have 3 over x minus 2 times something will give me something over x minus 2, x minus 3. I'm missing the x minus 3. Multiply your numerator and denominator by the same thing, and there is your first equivalent fraction. For my second equivalent fraction, this is the least common denominator. Kind of nice. So I have 2x over, and you're going to leave it in factored form, x minus 2, x minus 3. All right. Let's do it one more time before we actually start adding and subtracting. Neither one of these are factored. All righty, this first one, x plus 3, x plus 3. This second one, x plus 3, x minus 3. All righty, so this is in common. I'm only going to use it once. My LCD is going to be x plus 3 times x plus 3 times x minus 3. Now I am going to tell you not to make that the quantity of x plus 3 squared, because after we add or subtract in the next part of the lesson, we might be able to cancel something, and I want to keep factored form. All righty. Neither one of these fractions has everything I need, right? So I have x plus 1 over x plus 3, x plus 3. When I check my LCD, I am missing x minus 3. So I am going to multiply the top and the bottom by x minus 3. Thank you, Smartboard, for not picking this up. And my common, or my equivalent fraction, excuse me, is going to be, don't have space, so I'm writing down here, x plus 1 times x minus 3 over x plus 3, x plus 3, x minus 3. All right, second fraction, got to get that ready to add or subtract. So I have 1 over x plus 3, x minus 3. What am I missing? I am missing one of the x plus 3's. So x plus 3 over x plus 3, and this is going to be x plus 3 over x plus 3, x plus 3, x minus 3. And these two fractions are now ready to be added or subtracted. Finding the least common denominator is the hardest part. No doubt about it. So to add or subtract fractions, you have to rewrite the problem using a least common denominator. Then you add or subtract the fraction, right? You combine the numerators and you keep the denominator. Finally, you have to simplify the rational expression. Now, a lot of times addition and subtraction problems do not simplify, but you always have to check. SIMPL. Wow, I did not spell simplify right, did I? IFY. There we go. All right. Wow, I'm in luck. Common denominator. All right, so I'm going to write this out in factored form. My denominator is going to be y plus 3, y minus 3. Now, I have to add and I have to combine like terms when I'm adding, right? So we have y squared. I have positive 8y plus 2y, which is positive 10y, and I have a plus 21. Now I have to try to factor that numerator. Y plus 7, y plus 3, my denominator, does anything eliminate? And yes, the y plus 3's will go, and my final answer will be y plus 7 over y minus 3. That one was nice. I had a least common denominator and something eliminated and simplified at the end. The next one is not so nice. Okay. Parentheses around y plus 8, so I don't forget that that is a couple. Let's see. Y plus 8 and y plus 3. So my least common denominator is y plus 8 times y plus 3. And I need to multiply this first fraction by y plus 3 over y plus 3. So I have 7 times y plus 3 plus 35. Let's clean this up. Distribute. 7y plus 21 plus 35 over y plus 8 times y plus 3. Combine like terms in my numerator. 7y plus 56 over y plus 8 times y plus 3. Oops. Smart notebook doing weird things. Let's see, 7 goes into 56. 7 goes into 56 8 times, so I can factor this. I can pull out a GCF of 7. And I'm going to be able to eliminate my y plus 8. Final answer, 7 over y plus 3. Oh boy, that was a lot of work for one problem. Let's look at the next one. All righty. I do not have a least common denominator. I can factor this denominator. This denominator will factor to x plus 2, x minus 2. As I'm looking, the second fraction is missing the x plus 2. So what do I have? X squared plus 5x plus 6 plus, I'm going to distribute. 2 times x is 2x, and 2 times 2 is 4. And that is over x plus 2, x minus 2. Clean up your like terms. X squared, 5x plus 2x is 7x. 6 plus 4 is 10. Let's see, can I factor that numerator? I think so. X plus 5, x plus 2, divided by x plus 2, x minus 2. I can eliminate the x plus 2's, and my final answer, x plus 5 over x minus 2. So much fun. So much fun. Now, number 4 is tricky because of the subtraction sign. And you have to be really careful when you're subtracting to distribute the negative. All right, let's take a look. Let's see, x minus 9, x plus 5 is how that factors. And that means the second fraction is missing x minus 9. Okay. This is going to be x squared minus 9x. Now, here's what I'm talking about, the tricky. Distribute negative 2 to x, so negative 2x, and negative 2 to negative 9, so positive 18. Really watch subtraction. The mistakes happen all the time. Okay, combine like terms. Factor that numerator. Sometimes stuff will cancel, sometimes it won't. In this case, I can eliminate. Final answer is x minus 2 over x plus 5. I really thought I had spaced these out far enough, but I didn't. Sorry about that. All righty, last one, right? We are going to, see, this one doesn't factor, so I'm gonna put parentheses around it. This one does. 2x plus 5, 2x minus 5. So that's the common denominator. The first fraction is missing the 2x plus 5. It gets messy when that problem number is there. Okay. When I go to do this, the x has to be distributed to both of these. So that is going to be 2x squared plus 5x. And then this negative has to be distributed to both of these. So negative 4x minus 15. Good grief. 2x plus 5, 2x minus 5. Clean it up. 2x squared plus x minus 15 over 2x plus 5, 2x minus 5. Yes, I can factor that top. So let's see. 2x and x. If I do 2x times 3, that'll give me 6, and then minus 5 will give me 1. So a plus 3 and a minus 5. Negative 15. 6 minus 5 is 1. That is beautiful. I can eliminate. Final answer. X plus 3 over 2x plus 5. All right. Take a few minutes. and write your summary.